right, so section 1 is a review of important Algebra 2 concepts. So the first thing that we're going to do is we're going to talk about our exponents. Okay, so when you see something like the cube root of 64 raised to 2, right, you might also see that as 64 raised to the 2 over 3. So if you see it that way, you know as well. But basically, you're going to start with the inside the cube root and then raise it to the 2. So you're going to have the cube root of 64 is 4 squared, and 4 squared is 16. So when you see negative 8 to the 2/3, the 2 is your power, and the 3 is your type of root. So you're going to rewrite it as negative 8 is under a cube root, and then it's all going to be raised to a 2 for the power. So you take the root, I usually do that part first, and then I square it, and then I raise it to whatever power, right? So the cube root of negative 8 is negative 2, squared gives you 4. Okay, so you might see combinations. So in this one, I have 25 raised to the 1/2, and then I also have a 4 raised to the negative 3 over 2. So I'm going to do 25 raised to the 1/2 is the square root of 25, and then 4 to the negative 3 over 2. A negative power means 1 over. I'll wait till the end to do that. So I'm going to write it as 4 under a square root raised to the negative 3. So the square root of 25 is 5. The square root of 4 is 2, so I have 2 to the negative 3. And then there's two things you can do from here. So the first thing is when you see 2 to the negative 3, you can rewrite it as 2 cubed, but in the opposite location. So I could bring it up and write it as 2 to the 3 up there. Okay, or you could write it as 1 over. So I could also do 5 and then do divided by 1 over 2 cubed, which is 5 divided by 1 over 8. So then you can see that it's going to be 5 times 8 over 1, which is 40. So either way, you guys remember your negative exponents. All right, and then the AP Calc test likes using weird rules with E. So it's going to have lots of weird things in your multiple choice section with E. So we need to know how to work with that as well. So if I have 2e to the 3, that's going to be 8e cubed, right? Because 2e times 2e times 2e. Okay, and then this one's gotten a couple people earlier today. They think it's going to be e to the 1/5, but it's not e to the 1/5. What should this be? Yeah, Nick, what did you say? E to the 5 over 2, right? Because that's e to the 1/2, and then it's raised to 5, right? So it's e to the 5 over 2. And then we have e to the 9 over 3, right, which is just 3. So you're going to have 8e cubed over e to the 5 over 2, and then e to the 3. Which is kind of nice because the e cubes will now cancel out. So then you get 8 over e to the 5 over 2. So you can write that as your answer, or if you wanted to use a negative exponent, you could. It'd be 8e to the negative 5 over 2, like that. Okay, I would guess that the multiple choice would probably use a positive exponent. All right, so another thing that you do all the time in AP Calc is you use critical values. You put things on a number line, you test on the left, the middle, and the right. Okay, so I have 2x plus 4, or 2x squared plus 4x is less than or equal to 3. So the first thing that we do is we get everything on one side. So I do 2x squared plus 4x minus 3 is less than or equal to 0. You might write tiny on this one. I'm going to give you much room. That's never a good sign, is it, when your teacher says that? All right, and then you try to factor. Okay, so go ahead and look up here. You don't have to try to factor, because what happens is if you try to factor, when you put the 3 and the 1 in, it's like, oh, here I get 6x and I get 1x. That's not going to work, right? So then you're like, okay, well, what if I switch the 3 and the 1? But then what do we get? Like a 3 here and a 1 here. Then we have 2 and we have 3. And that's not going to combine to be 4x either. So we have a problem. So it doesn't factor. So what do we do when something doesn't factor? Quadratic formula. Yes, that's right. So if you've forgotten the quadratic formula, just summer was way too long, you could. Okay, that's the quadratic formula. It'd be hard with perfect square, or completing the square, because you'd have to take care of that too. You'd have fractions. So we're going to go ahead and find the critical value. So I'm going to do x equals negative 4 plus or minus the square root of 4 squared is 16 minus 4 times 2 times negative 3 all over 2 times 2. So you get negative 4 plus or minus the square root of 40 all over 4 And the square root of 40 breaks into square root of 4 and square root of 10, so 2 root 10. So negative 4 plus or minus 2 root 10 all over 4. And then we need to simplify down. So you can simplify down in two different ways. Okay, so the first way is to take the negative 4 divided by 4 and get negative 1. And take the 2 divided by 4 and get 1/2. So you could write it like that, negative 1 plus or minus 1/2 root 10, or root 10 over 2 if you want. Or, like that 4 can go into both. There's a girl I tutor always draws a heart, which I think is really cheesy, but I'll draw the little heart. And so then you take the GCF of all of them, which would be 2. So you get, divide everything by 2, and you have negative 2 plus or minus root 10 all over 2. I'm always worried Maury's going to come in when I draw the heart and make fun of me. All right, so we're not done with this problem. That would be if it was equal, right? But this is less than or equal to. So we're going to put those numbers on a number line. So if you find both of those values, I already found them. I think it's 0.518. Check for me. Okay, I still have it on my calculator, actually. Oh, someone cleared it out. Yeah, so that's 0.518. Or 581, sorry, and negative 2.581. So what we end up doing is we put those on a number line in the order that they come on the number line. And we test each location. So the long way of doing this is like we did in Algebra 2, and you're testing up here to see if it's true or false. So if you test a number on this left side, if I try like negative 3, and I'm testing to see if it's true or false, I end up getting some number. It ends up being a positive number. Okay, that is not less than or equal to 0. Does that make sense? You're trying to find things that are negative in the end. So you're just plugging in to see if they're true or false. But if I try 0 in the original, I have 0 plus 0 minus 3 is less than or equal to 0. Right, negative 3 is less than or equal to 0. You get a negative number. That works. We like that. Okay, but if you try a bigger number like 1, if I plug in 1, I get 2 plus 4 is 6, minus 3 is 3. Is 3 less than or equal to 0? No. So the easiest way to do this without doing any of this math that I just did with the checking is to think about what you know about the graph. Okay, so if I look back up here at the 2x squared plus 4x minus 3, if I say y equals 2x squared plus 4x minus 3, what shape is that? Do you know, Maggie? No? Yeah, sure. No, I said Maggie once, but it's fine. You can go too. It's a parabola, right? And is this parabola, does it open upwards or downwards? It opens upwards. I don't know why my screen's freaking out. All right, so it opens upwards. And what we just found were the zeros of the parabola. We just found that it crossed at negative 2 point something over here, negative 2.581, and positive 0.581. It's like that. Oh gosh, struggling. All right, so what we're saying is, where is it above or below 0? Well, here's the line y equals 0. Where is it less than or equal to 0? From here to here, right? That's what we want. We want to think about a parabola that's intersecting at these 2 points. Where is it below? It's below right there. So that's going to be your solution set. So it's going to be bracket negative 2.581 to 0.581. And that's going to be your answer. So that's a tricky one. There was a lot involved. But really, you know, if you think quadratic formula is hard, you're in for a rough year. Like, it gets a lot harder in calc. All right, so let's do the next one. We still have 5 minutes. I don't know why people are out running around. Right, we get out of 1:30. All right, so I'm going to subtract over. So I have x cubed plus 4x squared minus x minus 4 is greater than or equal to 0. And this one has 4 terms, so I'm going to split the middle. So I'm going to pull out an x squared, and I'm going to have x plus 4. Ideally, I want an x plus 4. Can that happen? What do I pull out? Yeah, negative 1, right? So now I have a GCF of x plus 4. So I can pull the x plus 4 to the front. When I do that, I have x squared minus 1 left. And x squared minus 1 factors even further. It's the difference of 2 squares, right? So it's going to be x plus 1, x minus 1. So I'm going to have x plus 4, x plus 1, x minus 1 is greater than or equal to 0. So I get 3 critical values. So I have -4, -1, and 1. So I put those on a number line. And I'm going to test in each location. Now again, if you use your knowledge of what these graphs look like, you're good. Because this is an x cubed graph. And x cubed graphs are ones that go like that. If it was negative x cubed, it would start on the top, and then as it goes, it would be decreasing, it would go down, right? But this is a positive x cubed, so it should look like that. So think about where it's going to be above the axis and below, right? It's going to be below, above, below, above. Okay, but if you don't know that, then test them. So you could test -5, maybe in the factored form. Let me write that. So if I test -5, oops, -5, I would have a negative number times a negative number times a negative, which gives me a negative, right? Is that greater than or equal to 0? No. So it's not going to be one of the answers, right? And then you could try the other ones. So basically, we want where it's greater than or equal to 0, we want the positive outcomes. So fill in the endpoints. So your answer is going to be bracket -4 to -1, union bracket 1 to infinity, like that. I'm going to pause.